Alright, welcome to the video. In this video, I am going to talk about the addition rule of probability. Okay, before we start with the addition rule, let me talk about the mutually exclusive events. What do you mean by mutually exclusive events? So the two events are mutually exclusive or disjoint if they cannot occur at the same time. That is, they have no outcomes in common. Okay, those types of events are called mutually exclusive or disjoint event. For example, when you toss a dice, the events of occurring odd numbers and even numbers are mutually exclusive, because when you toss a dice, then what are the outcomes in the sample space? 1, 2, 3, 4, 5, 6, right? If you consider event O of odd outcomes, then you can say that 1, 3, 5 is the events of all odd outcomes. And if you consider events of even outcomes, then you'll get 2, 4, and 6 that are the from the sample space, right? Look at the event O and E. They do not have anything in common. So these two are disjoint events. Okay. Example 2, when selecting a card, the events of red card and the black card. So if you pick a card from a deck of 52 cards, one card is the card that you picked will be either black or red. Okay, so black card and the red card, they do not have anything common, because a black card cannot be a red card or a red card cannot be a black card. They are disjoint. And example 3, in an experiment of flipping two coins, are the events A equals to no heads and B equals to at least one tail mutually exclusive? Let us look at that. In an experiment of flipping two coins, if you flip two coins, what will be the outcomes in the sample space? The first coin can be H, second coin can be H, first coin head, second coin tail, first coin tail, second coin head, or both coin tail and tail. These are the possible outcomes, right? What does the A says? A says no heads. No head means just TT, right? See, this outcome has both head. This outcome has the first head, the second tail. This outcome has first tail, the second head. But the A says no heads. This is the only outcome with no head, right? That is A is TT. Similarly, what is B? B is at least one tail, meaning we include all the outcomes with which has at least one tail. That means HT, HT, and then TH or TT. So these are the outcomes. So do you think event A and event B are disjoint? The answer is no, right? They are not disjoint, or they are not mutually exclusive, because they have something in common. So if the events have some outcomes in common, then we call joint events or overlapping events. Okay, but if they do not have anything in common, we call they are disjoint or mutually exclusive event. Let us look at the formula for the addition rule of probability. What it says is, if the events A and B are mutually exclusive, then the probability of A or B is equals to PA plus B. Meaning, if you want to find the probability of an event or another event, if the events are mutually exclusive, meaning if they do not have anything in common, then you add the probabilities. Okay, for example, if a dice is rolled, find the probability that the outcome is less than 3 or greater than 4. So if you roll a dice, what are the outcomes in the sample space? It is 1, 2, 3, 4, 5, 6, right? So what are the outcomes less than 3? Less than 3 will be 1 and 2 only, right? And then greater than 4 means 5 and 6. Do they have anything common? No. So they are disjoint, right? In case of the disjoint event, the probability of one event or the another event is basically you find out the probability of each of those events separately and add them. That's what it says, right? Less than 3 or greater than 4 is probability of less than 3. That means the probability of this, how many outcomes are there? That is 2 outcomes out of 6, because the total in the sample space is 6, plus how many outcomes in the greater than 4? There are 2 outcomes, so out of 6 outcomes. So that's what you do. Okay, so 2 over 6 plus 2 over 6, that is 4 over 6. And if you simplify that, if you divide the top and bottom by 2, you will get 2 over 3. Let us look at example 5. two dice are rolled. Do you remember how do you find out the total outcomes in the sample space when two dice are rolled? It is sample space will be like 1 in the first, 1 in the second, 1 in the first, 2 in the second, and so on. And similarly, 2 in the first, 1 in the second, 2 in the first, 2 in the second, and so on. And you continue that way. And then the last one is 6 on the first, 1 in the second, 6 on the first, 2 in the second, and so on. So in this way, you will get 6 outcomes in each row. So the total will be 36 in total. So the total number of outcomes will be 36. What it says is, two dice are rolled, find the probability that the sum on the top is either 8 or 6 or 12. So how many outcomes will have sum 8? Sum 8 will be the outcome, sum 8 will be 2, 6 or 6, 2. Because 2 in the first dice and 6 on the second dice, or 6 on the first dice, 2 in the second dice. Another is 5, 3 or 3, 5. And then the last one is 4, 4. These are the outcomes whose sum is 8. Similarly, sum 6 will be 5, 1, 1, 5, right? Similarly, 2, 4 and 4, 6, and then 3, 3. So these are the outcomes with sum 6. How about the sum 12? Sum 12. How many outcomes are there? Sum 12 have this is basically 6 only, right? All other outcomes will not have sum 12. So look at this. Do they have anything common? There is 2, 6, 6, 2, 5, 3, 3, 5, and 4, 4. There is 5, 1, 1, 5, 2, 4, 4, 6. 2, 4, 4, 2, not 4, 6, 4, 2, and 3, 3, and this is 6, 6. All of them are disjoint. So this formula of A or B can be extended to A or B or C. If they are not joined, meaning if they are disjoint, then the probability of this or that or this is equals to probability of A plus probability of B plus probability of C. You can do that way. You can extend this formula of the two events into the formula for the three events if they are disjoint. So let's look at what I written here. When two dice are rolled, there are total 36 possible outcomes. We talked about that already. The sum of the top can be 2, 3, 4, 5, and then so on through 12. That is the maximum possible sum you can have. And this is the minimum possible sum on the top. Only one outcome, 1, 1 has sum 2. Two outcomes, 1, 2, and 2, 1 has sum 3, and so on. There are 5 outcomes with sum 6. 5 outcomes with sum 8. We counted that there already. And only one outcome with sum 12. So if you want to find a sum 6 or sum 8 or sum 12, then you can find out the probability of them separately and then add them. Okay, so 5 out of total is 36 plus 5 out of 36 plus 1 out of 36 will be 11 out of 36. So this is the formula if the events are disjoint, meaning if they do not have any outcome in common. But if they have some outcomes in common, meaning if A and B are not mutually exclusive, then the probability of A or B is PA plus BE is same as the previous one, PA plus PB, right? But you need to subtract the common one. How many common do they have? You need to subtract that. Okay, so you need to subtract the probability of the common. Let us look at this example. If a dice is rolled, find the probability that the outcome is an odd number. So probability of odd number or less than 4. Less than 4. So how many outcomes are odd numbers? So the sample space is 1, 2, 3, 4, 5, 6, right? What is the odd number? Is 1, 3, 5, right? And what is the less than 4? Let us denote that by L. Is 1, 2, 3. So is there anything common on less than 4 and odd number? Yes, there are, right? 1 and 3 are common. So the common is common. We denote by A and B. That is the common. Okay, that can happen on both. Common is 1 and 3. So let us find out that P, O or less than 4. The formula is PO plus P less than 4 minus P, O and less than 4, right? And less than 4. So this is what it says. You need to subtract the probability of the common. So what is the probability of odd? How many are in the event O? There are 3, right? 3. How many are in total in the sample space is 6 plus. Probability of L. L is the less than 4. That is, there are 3 outcomes that are less than 4. So 3, the total number of outcomes is 6 minus odd and less than 4. How many are there? There are 2, right? So 2 out of 6. So if you add them, you will get 3 out of 6 plus 3 out of 6 is 6 out of 6 minus 2 out of 6 is 4 out of 6, right? That is basically 2/3. This is how we find out the probability of or if they have something in common. Let us do example 7a. 2 dice are rolled. Find the probability that the sum is multiple of 4 or 6. Let us denote the sum multiple of 4 as A is sum multiple of 4. That is the sum is equals to sum is multiple of 4 means 4 or 8 or 12. These are the sum 4, 8 or 12. That is A, right? So what will be B? B is sum multiple of 6, meaning 6 or 12, right? So now let us list the outcomes that has sum 4, 8 or 12 and sum 6 or 12. So how many outcomes are there? So there are, what are the outcomes with sum 4? 1, 3 and 3, 1. Another is 2, 2. These are the sum 4. How about the sum 8? Multiple means the number that divides by 4, right? So what are the outcomes with sum 8? We listed that already, but let's list that again. 2, 6, 6, 2, right? 3, 5, 5, 3, and then 4, 4. And sum 12 is 6, 6. These are outcomes with sum multiple of 4. These are the outcomes with that. How about sum multiple of 6? That is 6 or 12. That will be 1, 5, 5, 1, right? And then 2, 4, 4, 2, and then 3, 3. These are the sum multiple of 6. And then sum 6 is this many, and sum 12 is just 6, 6. Now, so how about A and B? What are the common there? A and B will be, so look at this, the common 1, 5 and 5, 1 is not common there. 2, 4 and 4, 2 is not common there. So what is the common? Common looks like only 6, 6 is the common one on those two, right? So 6, 6 is the common. So to find out probability of A or B, the formula is PA plus PB minus probability of A and B, right? So what is PA? PA means how many outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is 9 out of 36 plus PB is 1, 2, 3, 4, 5, 6. So 6 out of 36 minus probability PA and B. How many are there? It's just 1, right? 1 out of 36. So how much is that? 9 plus 6 is 15 minus 1 is 14 out of 36 is the probability. And then divide by 2, you will get 7 out of 18. So this probability, if you want to write this probability in the decimal form, what do you get? You get 7 divided by 18 is basically 0.3888. So 0.3888 and so on. So you can write, if you want to do with 3 decimal places, you can write 0.389. okay? So is this event likely to occur? So if the probability is very small, we say it is unlikely to occur. For example, if it was like 0.00001 or so, then we can say this is unlikely to occur. But since the probability is like 38.9%, so in this case we say that the event is likely to occur. Okay, so this is how we do. So meaning that if the event A and B do not have anything common, then the formula of A or B is PA plus PB. But if they have common, you need to do PA plus PB minus you subtract the probability of the common part. Okay, let us do example number 7b. In a study of 400 patients, it was found that out of 130 alcoholic patients, 109 had elevated cholesterol. from 270 non-alcoholic patients, 61 had elevated cholesterol level. If a patient is selected randomly, find the probability that the patient is alcoholic with elevated cholesterol, non-alcoholic, and non-alcoholic with non-elevated cholesterol. Okay, so we want to answer these questions, and the last one is that has or in it. Okay, so let us first of all make, if the problem is given is like this as a word problem, it is always better to make a table and then see the clear picture. Okay, so the total number of patients were 400, and 130 were alcoholic and 270 were non-alcoholic. Okay, so let us do alcoholic and non-alcoholic. Okay, and then we can do the total is here. Okay, so and then also we need to write down the information given there too. So let us find out the total here too, total, and then total here. Okay, now let us look at this. What I did say is, out of 130 alcoholic patients, the total alcoholic is 130, and then out of 270 non-alcoholics, the total non-alcoholic is 270. That is given, and if you add that, the total of the total is 400. Okay, now out of 130, how many? 109 had elevated cholesterol. Let us denote the elevated cholesterol by NEC and the non-elevated cholesterol by NEC. So this is the elevated cholesterol, these are the non-elevated cholesterol. What does it say is, out of 130 alcoholic patients, 109 had elevated cholesterol. So 109 are there. So how many will be there? There will be 21, right? Because the total is 130. 109 were had elevated cholesterol. So non-elevated cholesterol out of the alcoholic patient is 21. So that the total sum is 130. Similarly, in the non-alcoholic patients, out of 270, 61 had elevated cholesterol. 61. So how many will have non-elevated cholesterol? It will be 209, right? Because the total will be 270. Now let us find out the total elevated cholesterol here. So how many are total elevated cholesterol? So you need to add these two. So you will get 170 here, right? And then the total non-elevated cholesterol patients will be 200 and 230. That is the, so this completes the table. Now from this table it is easy to answer all the questions. Let us look at the first one. It says, if one patient is selected randomly, find the probability that the patient is alcoholic with elevated cholesterol. So alcoholic with elevated cholesterol means it should be alcoholic and it should have elevated cholesterol. How many are there? Alcoholic and elevated cholesterol is 109, right? Alcoholic with elevated cholesterol. You can write N here, okay, or whatever you want to denote there. Elevated cholesterol is basically that there are total 109 divided by the total of the total is 400. So let's see, the second one is non-alcoholic. How many are non-alcoholic? The 270, right? So the probability of non-alcoholic is, the total non-alcoholic is 270 divided by the total of the total is 400. That's how you find out that. And then the next one is non-alcoholic with non-elevated cholesterol. So look at the column of non-alcoholic and the non-elevated cholesterol is how many there are? There are 209, right? Probability of non-alcoholic with non-elevated cholesterol, right? This is just the notation. You can give any name there. So it is basically 209 over 400. And the last one is alcoholic or non-elevated cholesterol. Let us look at that. A probability of alcoholic or, it says or, non-elevated cholesterol. Okay, so do they have anything common? Let's look at the alcoholic and non-elevated cholesterol. Is alcoholic? Yes, there is 21 in common, right? Alcoholic column is this, and the row of the non-alcoholic non-elevated cholesterol is this one. So 21 is common. So let's use that formula there. So probability of A plus probability of NE non-elevated cholesterol minus probability of A and non-elevated cholesterol. So let's find out that probability of A is 130 divided by 400 plus probability of NEC is how many were there? And EC 230, right? So 230 over 400 minus this is 21, because alcoholic, the first column and then second row is 21, that is the common, 21 over 400. So how much is that? 130 plus 230 is 360 minus 21 is 339 divided by 400. This is how you answer this question, okay? Because if there is or, if they have anything common, you need to subtract the n part, subtract the common part. Let us look at the example number 8. It is better if you make the table here again, because it is the word problem, right? So at a used book sale, 100 books are adult books. So there are what types? Adult books. And then it's like then another type of book is children book, right? Let's do and children book, right? So what it says is the total number of adult books is 100. So the total, let's write down total is 100 adult books and then 160 children books. So we'll write total here, okay? This will be the total of the total. Now, of the adult books, out of these adult books, 70 were non-fiction, where 60 of the children books were non-fiction. Let's write down, this is fiction, this is non-fiction, okay? So what it says is, out of the adult books, 70 were non-fiction. 70 were non-fiction. And then how many are fiction then? Because the total is 100, it must be 30, right? Similarly, in the children's book, 160 out of 160 books, 60 books were non-fiction. 60 were non-fiction, so how many must be fiction? 100 must be fiction. So the total of the fiction is 130. And the total of non-fiction is 132. And then total of the total is, you can add this way or that way, either way, 260. The total number of book is 260. Let us answer the question. This completes the table, okay? Now, if a book is selected at random, find the probability that it is a fiction book. Probability of fiction. How many fiction books are there? 130, right? The total number of fiction is 130. 130 divided by the total of the total is 260. So you can simplify and get the decimal, okay? So if you do that, I think you will get 1/2 or 0.5, okay? Next is not a children's non-fiction book. What do you mean by not a children's non-fiction book? So you can do, this is not, meaning you can write, you can find out this, let me find out here. You can find out this by using the complement, right? It says complement of children's non-fiction, right? So the complement of the children, so for the complement we do the bar, right? It is 1 minus probability of children's non-fiction book, children's non-fiction, you can write that way. Or you can do it directly too, I can show you both, right? 1 minus, how many are the children's non-fiction? What is the probability of children's non-fiction? So this is the column for children, and non-fiction is 60, right? So 60 over 260 is the probability of children's non-fiction book. So how much is that? 200 over 260? 260, right? So that will be how much? 10 over 13. This is one way. The another way of doing it directly without using the complement is like this. So how many? It says not a children's non-fiction. So this is the children's non-fiction. Everything except this is the not a children's non-fiction. So you can add 100 plus 30 is 130 plus 70 is 200. You can do directly like 200 over 260 and then do 10 over 13 too. You can do it directly because it says not a children's non-fiction means everything except children's non-fiction, right? So you can count that way too. Okay, next is an adult book or a non-fiction book. It says probability of adult book or let me write down that it should be or here. So it should be or. So you get probability of A is the adult or non-fiction. Adult or non-fiction, okay? So do they have anything common? Adult is here, non-fiction is here. So they have common, 17 common, right? So the formula is probability of A plus probability of non-fiction minus probability of adult non-fiction, because probability of A plus probability of B minus probability of A and B. You can write and here if you want to in the middle, okay, that if that helps. But the formula is basically you add the separate probability minus subtract the common in the both. Probability of adult is, the total adult is 100 over 260, right, minus probability of non-fiction is 130 over 260, plus here 260 minus the common is basically adult and non-fiction is 17 common, so 70 over 260. If you do that, it is 230, 100 plus 130 is 230 minus 70 will be, I think it is 160, right, because 230 minus 70 will be 160 divided by 260. If you just cancel 0 and 0, you will get 16 over 26, that will be 8 over 13, or you can find out the decimal value there. So this is how we find out this, okay. So we will do a couple more examples there, all right, and then we will start the multiplication rule. Let us do example number 9. According to the Bureau of the Census, the following statistics describe the number in thousands of young adults living at home or in dorm in the year of 2004. So here the table is already given, so you don't have to make the table, but only thing you need to do here is you need to find out the total, because to find out the probability you need to find out the total of each category, okay. So find out the total here and also find out the total male and total female as well, and also we will find out the total of the total, okay guys. So let me find out the total by using the calculator. All right, so if you add the total, if you want to find out the total number of the ages between 18 and 24, you add these two, you will get 13701. You will get 13701. This is what you get, okay. And if you add 25, 34 and 995, then you will get 3529. And then if you add the total number of males, it will be 10456, and this one will be 6774. Now we need to find out the total of the total, right? So what do you get for the total of the total though? So this will be 6 plus 4 is 10, 7 plus 5 is 12, 13, 4 plus 7 is 11, 12, so 10 plus 7 6 is 16, plus 1 is 17. So the total of the total is 17230, that is 17,230. Let us answer the question here. Choose one student at random. Again, so if the table is given, you need to find out the row total and the column total, okay. And if the table is not given, you need to find out first, fill the information in the table like in the previous example, and then find the row total and column total, and then you answer the question. So choose one student at random. Find the probability that the student is a female student, age 25, between 25 and 34. So female, age between 25 and 34 is that many, right? So it is probability of female in that category, 25 to 34 subscript, is equals to 995 over 17230. Okay, this is how you find out, and you can use calculator to find out the decimal there. Male or age between 18 and 24 years. It says male or, okay, so you should do probability of male plus probability of 18 to 34 minus probability of male and 18 to 34 years of age, right? So what do you do? What is the probability of male? The total male is 10,456 over 17,230, because the total male over the total of total, plus what is the probability of 18 to 34? The total of that is 13701. So 13701 over 17230 minus the common. What is the male? The male and between that is 7922, right? So 7922 over 17230. Just use the calculator to find out the final answer, right? So if I use the calculator, this is what I get, okay? So if I add the top, you will get 16235, and subtract this, so add those two and then subtract this is what you get, and the bottom, they have the same bottom, so it stays the same. And if you use the calculator, you get 94.9422. So this is highly likely to happen, right? Because the probability is almost 1 means almost sure to happen. If the probability is too small, you will say unlikely. If it was like 0.0156 like that, so in that case it will be unlikely. All right, the next one is under 25 years of age and not male. And means you should find out the common, right? So not male means female, and under 25 years means that, right? So how do you find out that? Is basically the probability of so under 25 years, okay, and then not male, that means same as saying female of 18 to 24 years, right? That's what it is saying. You see that? Not male means female here, and then under 25 years means the age group 18 to 24. So how many are there? 5, 7, 7, 9 over the total of the total is 17,230. So if you do that in your calculator, you will get 5779 divided by 17,230 implies 0.3354. 0.3354. This is what you get. Okay. All right, let us take a couple more examples here. So if it is similar, I will leave it for you. Okay, so let's see. A local postal carrier distributes first class letters, advertisements, and magazines for a certain day. She distributed the following numbers of each type of item. Who goes to home is first class, that many first class, that many ads, that many magazines. Goes to the business, that many first class, that many ads, and that many magazines. Again, if a table is given, you need to find out the total of the rows and columns, right? You need to find out the total, and then total of the total. Find the total here, find the total here, and find the total here too. The total of the total will be same either if you add row wise or column wise, you will get the same. Okay, now find an item of male is select. If an item of male is selected at random, find the probability of item went to home. So probability of home will be, how do you do that? Is you find out the total home, okay, that over the total of the total, you find out that yourself. Okay, number B is the item was an ad or it went to a business. How do you do that? Item of an ad or went to business. So do they have common? Ad or went to business? Oh, that is the common one, right? So what do you do? Probability of ad plus probability of business minus probability of ad and business. That's what you do. And what is the probability of ad? Is the total ad divided by the total of the total. Okay, that's what you do. Let's say this is say you get that circle, the total. Okay, total is that divided by the total of the total plus probability of B. What is B? B is going to the business. How many are going to the business? That's 2 star. Let's say you find out the total sum is 2 star. That will be 2 star over the total of the total minus the ad and business is 1021, right? 1021 divided by that. So you basically plug in those numbers there and then you get the final answer. Okay. All right. The item was a first class letter or it went to home. Exactly the same way. So probability of first class letter or went to home. This is or. Okay. So it will be probability of first class plus probability of home minus probability of the first class that went to and home. So what is the probability of first class? Is you need to add them. So if you add them, you will get 7,575 over, find out the total of the total plus probability of home. How many went to the home? You add that 1 star divided by that minus probability of first class and went to home. So that is 325, right? So 325 divided by, so you use calculator to find out those and then you will get the final answer there. Okay. How about the last example? So the last example is, it says a social organization of 49 members sold college sweatshirts as a fundraiser. The result of their sale are shown below. So number of sweatshirt and number of students. So 0 sweatshirt. So these are the total number of students who were the sellers, okay, who were selling these sweatshirts. So 3 students sold no. 15 students sold between 1 and 5, 12 students sold between 6 and 10, 9 sold between 11 and 15, 9 sold between 16 and 20, and then only one student sold more than 20 sweatshirts. Okay, now the question is, choose one student at random. You are picking one student out of 49 because you need to find out the total here. Total is 49 because that's what it says, right? Find the probability of the following enter your answer as a fraction or decimal rounded to 3 decimal places. You can leave it as a fraction or do the decimal into 3 decimal places. So first one is probability that the student selected sold more than 10 sweatshirts. What is the probability that he or she sold the more than 10? More than 10 means 11 to 15, 16 to 20, or 21, right? So it is probability of greater or equals to 10 will be probability of 11 to 15 is greater than 10 plus probability of 16 to 20 is also greater than 10 plus probability of 20 plus is also greater than 10. Or you can count like this: 9 plus 9 is 18 plus 1 is 19 out of 49. You can do that way. Students sold at least 11. At least 11 means the same thing, right? Basically at least 11 means 11 or more, right? So it is also probability of by the way, more than means not the, by the way, let me correct that because you do not count 10 here, right? Okay, because when you say more than 10, it is not equals to 10, it is greater than 10. And at least 11 mean also probability of greater or equals to 11 here. So you count that same 11 to 15, 16 to 20, and 20 plus. That will be also 19 over 49. This is what you get. Okay, guys. So you will see the similar examples in your online homework. Okay. All right.